Gang, it can be confusing sometimes when we are talking about RF and we run into both frequency and wavelength. And that's because these are interrelated terms. So link them in your mind together as we're dealing with RF. Specifically, frequency can occur in all sorts of things in physics. I mean, a planet orbiting the sun, like Mercury, has a very high frequency of orbit, whereas Neptune has a much slower frequency in which it makes an orbit around the sun, right? So that's frequency. It applies to all sorts of things that have a periodicity. However, wavelength is specific to waves. And what it's describing is the length that it takes for a particular part of that wave, we'll say the crest of the wave, to reach the crest of the wave again, right? Because that sine wave pattern has a high point and it has a low point and then it reaches that high point again. How long does it take to get between high points or between low points? It's the same distance, or between medium points, equivalent distances in that wave. What we find is that as we increase our power, we're going to increase our frequency. And we see that right here. See how it takes more power, we talked about this before, to generate the effect here of a higher frequency. However, as we do increase the frequency at which a particular wave occurs, the distance is shorter. Literally, it takes less distance as it is transmitting to get from the crest of the wave to another crest of the wave. If we have lower power, what we generally see are longer wavelengths. It takes longer before we reach that crest again. Things that have a low frequency will tend to have a long wavelength. It's literally measured in meters. How long does it take? Now, I say it's measured in meters, just like you have frequency measured in hertz, but then as we get to greater and greater frequencies, we go to megahertz and gigahertz. As we deal with wavelength, it's defined in meters, but in order to describe the wavelength of things that might be occurring, for example, in the gigahertz range, we're talking about fractions of a meter, millimeters or picometers. We can get very, very small as we're describing the distance that it takes to go from one crest to another. So all this, again, is based on, in our world, as we're dealing with the wavelength of things that are transmitted wirelessly, the movement of electrons that generate that electromagnetic field, that's the electromagnetic wave that carries information. And so things that have a low wavelength and tend to have things with a long wavelength have a low frequency, which means they tend to travel farther. I mean, think about the booming bass that comes out of someone's car as they're listening to some music. You hear that bass a lot farther away than you hear the treble, the higher pitch, the higher frequency notes that are coming out of that same stereo system. And that's because those items, the higher pitched items, have a shorter wavelength. They have a higher frequency, a shorter wavelength, and therefore we find that they don't travel as far.